super easy. Whenever you have a y equals just a number, that is a horizontal line. So whenever you see y equals, you think horizontal. And you just put a horizontal line at that y value. So this is very easy to answer the questions that they asked us earlier then. If they're talking about an x-intercept, there's none. For the y-intercept, you know it hits at 0, 3, because here it is. And for a slope, the slope of a horizontal line is always 0. So if you ever get one of those, that's really nice. Hopefully you'll get at least one of those on the test. And the next one works almost exactly the same as the y equals. When you see x equals a number, that's a vertical line. So I just draw a vertical line at that number. X equals 4. I know that my x-intercept, or in other words where it crosses the x-axis, is at 4. So I write down 4, 0. The y-intercept, there isn't any because it never crosses the y-axis. And my slope we talked about earlier, we're not going to use the phrase no slope. We're going to say our slope is undefined. So whenever you have y equals, it's horizontal. Whenever you have x equals, it's vertical. Okay, the next two problems kind of do the same thing, but approaching it in a little bit different way. One's going to talk about parallel, one's going to talk about perpendicular. One of the things I want to tell you about is in our class, we're going to talk about this thing called general form. Sometimes they also call it, I think, standard form. So if you ever see those two phrases, basically what it means is that you have something x plus something y equals a number. And earlier we did two problems where I said, hey, you can plug in the zeros for these, that makes it really easy to graph. That's called general form or standard form. So when it's that way, I like to graph with the intercepts. It's really easy. There's some rules about the a and the b. Rule number 1 is that a and b are integers. What that means is you can't have decimals or fractions, square roots, that kind of stuff. They have to be like the numbers 1, 7, negative 12. Okay, so no fractions. So a, b, and c, I should say a, b, and c, pardon me. A, b, and c are integers. Also, the a is positive. So on your test coming up on Monday, you will have to know that you can't have any fractions or decimals, and when you have the a, it has to be positive. Because there's going to be a question for sure, at least one, if not more, about general form or standard form. Okay, no fractions, no decimals. The a is positive. A and b with the x and the y are on the left side. So it goes a junk with the x, b junk with the y, equals number junk on the other side. And I'll show you how to do a couple of those. Just so you know. So now let's try a problem. We're going to do the slope-intercept form of a line passing through the point 4, negative 2, parallel to the line 6x minus 4y equals 12. And then after we find the slope-intercept form, we're going to do the general form. So now I notice that they gave me a point. So in the back of my head, I'm already thinking, hey, if they give me a point, if I knew the slope, I could do the point slope right away. So I'm going to use that to my advantage. Take a look at this equation right here. In that equation, if I rearrange it, I could get the slope-intercept form of the line that they are talking about to begin with. So as I work with this equation, I'm going to move the 6x to the right-hand side. If I do that, I get negative 4y equals 12 minus 6x. So all I've done is move the 6x to the right-hand side. If I divide every single piece by that negative 4, my equation that I end up with is y equals negative 3 plus 3/2 x. Why would I want to do this? What does this give me? The slope. Very good, Lola. This gives me the slope. So now I know that I have a slope and I have a point. Point slope. This is the point slope form of the line, if I put it in an equation format. So this was the line they gave me. I don't want this. All I wanted from this line was its slope in the green highlight. Now I need to use the green highlighted point to create an equation. When I do that, my equation looks like this. Y minus negative 2, which is the same as plus 2, equals my slope, 3/2, times x minus 4. So the pieces that I used were my point, 4, negative 2, which you can see in the orange equation, and my slope, 3/2, which was in the blue equation. So I had a point and I had the slope. I put it in the point slope form of the line. If I want to put this in slope intercept form, I probably should distribute the 3/2 to each of the pieces in the parentheses. So now, in order to change this, when I multiply the 3/2 through, I will get y plus 2 equals 3/2 x minus 3/2 times 4, which is really like 4 over 1. So you need to be comfortable multiplying fractions. Or in other words, y plus 2 equals 3/2 x minus 12 over 2, which is 6. And I'm still not in slope-intercept form because the 2 is on the left. So if I move the 2 to the right, I have y equals 3/2 x. And then if I move the 2 to the right, it becomes negative 2. So I have minus 6 and minus 2, which is minus 8. Now this equation is the answer to the first part. This equation right here is the slope-intercept form. So I've now answered the first part of the question. Second part was put it in general form. What's the first rule about general form? They have to be integers, no fractions, right? I look down and I see that there's a fraction. There's halves. How would I get rid of division by 2? Multiply by 2. So I'm going to get rid of what I see on the bottom by multiplying every single term by 2. So whatever you do on one side of an equation, if you do the exact same thing on the other side, then it balances out. So you can add 5 to both sides of an equation, you can divide both sides by 7, you can multiply both sides by 3, whatever you want to do, as long as you do it on both sides, you're good to go. So I'm going to multiply both sides of the equation by 2, which actually means you're changing every term by a factor of 2, because then it holds its truth. So as I do that, and I look at what happens to this equation, when I multiply everything by 2, I will get 2y equals the 2 times the 3/2 cancels out the 2. So I just get 3x. That's the whole purpose of why we're multiplying by 2, to get rid of that division by 2, because they cancel. And then I have negative 8 times 2, which is negative 16. Yay, no fractions. Second rule, has to be x's, y's, and then equals a number, right? My x is on the wrong side. So now I move it to the left-hand side. As I move that to the left-hand side, I will get negative 3x plus 2y equals a negative 16. So now the good news is, number 1, there are no fractions. Number 2, they're lined up in order. X's, y's equals numbers. Third rule is x has to be positive. So I need to do one more thing. The last thing that I have to do is I have to make the x positive. I can either do that by multiplying by -1 or dividing by -1. Doesn't matter, because in the end, here's what happens. Whether I multiply or divide by -1, every sign changes, and that's the end. So now I have my other answer, the answer that I wanted to finish with, which was the same equation of the line in general form. So in the pink highlight was the slope-intercept form. In the yellow highlight down at the bottom right is the general form. All of the numbers are integers. They're lined up x's, y's equals in a number, and the x thing is positive. In -7, other than the word perpendicular, everything is exactly the same. Everything. I know from the previous problem, if I look back, that when I change this equation that they gave me, not the one I'm looking for, but the one that they gave me, that the slope from that line was 3/2 in the green highlight. Remember that? 3/2. So as I look at number 7, what I know is that the slope from this line right here, it has a slope of positive 3/2. And that's all I really care about that line for. That's it. The reason I care about that is when I talk about the perpendicular slope, which is what I want, that means the perpendicular slope is when I flip the fraction and change the sign. Flip the fraction, change the sign. That means the slope that I want for the perpendicular one is -2/3. This is the important slope. I'm going to use that slope, and I'm going to do the exact same process. Bless you. So as I use that slope to use the same exact process, what that means is the way that I start out, just like in problem number 6, is y minus -2 equals, and this time instead of 3/2, I go -2/3 parentheses x minus 4. So I put the stuff in the slope-intercept form using the perpendicular slope that I knew because I flipped the fraction and changed the sign. And notice that the point that I used for -2 is still there. So same exact problem. Instead of using 3/2 to start out with, I use -2/3. The same process. For today, what I want you to do is I want you to try and finish off this problem, number 7. My answer is online and will be up in the binder. You can also use my iPads. And then you have the rest of the class period to finish P3 worksheet and maybe get started on the review. Tomorrow's a review day. Binder's up in front. iPads are up in front. Help yourself.